Okay, so here's your warm-up. We're going to pause the video so that you can start this problem, and then we'll unpause it so you can see my work and check your answers. First, I have to find the determinant, which is 1 times 7 minus 1 times 8, and that's negative 1. So the inverse is 1 over the determinant. Switch your first diagonal. Make the others negative. And then distribute your determinant to each piece. So your final answer should be the matrix negative 7, 8, 1, and negative 1. The answers to last night's homework are on Edline in yesterday's flip chart and in this one, so please check on your own time. So today we're going to talk about solving matrix equations. So my first question to you is, how would you solve 2x plus 1 equals 7? Think about the steps that you would take. So the first step, you would say subtract 1. And that's called the additive inverse. You're doing the operation that is the opposite that cancels these out. And then you're left with 2x equals 6. Then what would your next step be? You're going to divide by 2. Or multiply by a half. We're going to stick with the multiply by a half. That's called the multiplicative inverse. And your answer is 3. So using this process of multiplying by a half is how we're going to solve a matrix equation. So the first step is we need the multiplicative inverse for this matrix. The order matters in the way that you multiply your matrices. So we're going to talk about that in a second. I'm going to call this matrix A. X is the matrix we're going to find, and this is matrix B. So to find A inverse, I need 1 over the determinant. Do that up here. Negative 7 minus negative 8. Ooh, that's 1. That's really nice. So then the inverse is I switch those, make the others negative. So A inverse is negative 7 to negative 4 and 1. So if I'm going to solve this equation, which is A times X equals B, I need to multiply A inverse on this side, which is like this 1/2 times 2. But since order matters, I need to do A inverse and then B. It cannot be B then A inverse. The order matters. When you multiply an inverse by the original, you get the identity matrix, which is why it cancels it, or it makes it that value of 1, just like here 1/2 times 2 is 1. So our matrix X is going to be A inverse times the B matrix. And now we have to multiply our matrices together. And be really careful with your order. So we're going to pause the video so you can multiply these. Remember, row by column. So this first row is negative 49 minus 2. And then the top row in the second column is negative 14 plus 18. Now the bottom row in the first column is negative 28 minus 1. And then the bottom row in the last column is negative 8 and 9. And when you simplify, you should get negative 51, 4, negative 29, and 1. We're going to do the same thing with number 2. I want you to write the problem down. The first step, I'm going to label these again, A, X, and B. is to find the inverse of A. And luckily, the determinant again is 1. 6 times 6 minus 5 times 7. So we just have some reorganization to do. And there's our inverse matrix. I want you to set it up. What is the multiplication that you're going to do in this next step? I want to make sure your order is right. So we're going to pause the video while you set that up. So you should have A inverse times A times X equals A inverse times B. This order matters. A inverse times A, that's a matrix of 1. So there's my A inverse and my B matrix. Now we need to multiply row by column. So take a minute. We're going to pause the video so you can multiply those together. And your answer should be this matrix. So check to make sure your numbers match. I'll talk you through some of the work. 6 times 1 plus negative 21 is how we got negative 15. 6 times 0, negative 7 times 1. 6 times negative 2, negative 7 times 4. Negative 5 times 1 plus 18. 0 plus 6. And then lastly, 10 plus 24. Now for example 3 here, we have this extra matrix. So I'm going to go back again for 1 second, and it looks exactly like this first one. 2x plus 1 equals 7. And you subtracted that 1 first. So to start example 3, we will subtract first. And again, order matters. When we subtract here, these matrices cancel, but this negative has to be with that matrix that you're subtracting to the other side. We'll bring this piece down. Now subtracting our corresponding positions, 6 minus 2 is 4, 2 minus 7, negative 2 minus negative 3, that's really addition. So we get 1. And then 3 minus 4 is negative 1. And now it looks like the other two problems we just did. So we're going to pause the video for you to find the inverse and solve the equation. Your answer should be this matrix here in the gray box. That's your answer. I'm going to show you how I got that. The inverse of this, the determinant is 1 again, so the inverse is switching and making these negative. So I need the inverse on this side first. I'm going to bring down the other matrix. These cancel to be an identity matrix of 1. And when you multiply row by column, you get 8 minus 7, negative 10 plus 7, negative 4 plus 4, and positive 5 minus 4. And that's our answer. Okay, here's another example. We're going to pause the video for you to try number 4. Your first step should be to subtract this matrix to the other side. minus 3, 9 minus 4. Now we need the inverse. So here we have negative 35 minus negative 36 for my determinant. That's 1. So my inverse, switch the first column, make the other negative. So when I go to multiply to solve this, I need my inverse first. And then the other piece. And to multiply, row by column, your answer should be this one here in red. For whatever time is remaining in class, here are your homework problems. Make sure to check all of your answers on Edline Tonight in the back of the flip chart, or in the back of your book, at least the odds.